Hey guys, I'm Isil Khan, and in this video we'll be learning about the cut in fill calculation for an irrigation channel, and of course I'll focus on the given example. Okay, this is example 22. Okay, so it is given, okay, with some data, you can say. The only thing we have to do over here is to calculate the earthwork for the given channel. Okay, we got here two sections. One section represents the cut, okay, and the another represents of course the fill. Okay, all right, so to estimate the cut and fill for the given channel, of course there can be many methods, like you can say the mean area method, the mean depth method, prosmodial method, trapezoidal method, and so on. Okay, there can be many methods, but in this video I'll focus on the mean depth method because this method was already uploaded for the earthwork calculation of road or in embankment, you can say. So we got over here RD, or reduced distance, you can say. It was given the NSL, natural surface level, and FL or formation level, you can say, the depth, mean depth, and these are the areas, you can say. Okay, the summation of area, the distance, and then we'll calculate the cut and fill quantities. Okay, so we got something that are given in the example terms, like you can say the RDs, those are 800 and 830. Okay, it is 30 interval, you can say. So I'm gonna put all these videos who are here in this column, the column of RDs. Then the NSL, it is already given over here, so I'm gonna put these videos in this column as well. Now FL, here we got only one FL for the RD 800. Okay, it is given over here. Bed level of RD equals 800 is 233 meters. Okay, so this is the formation level at RD 800. I'm gonna just put this video over here, just there. Okay, all right. Now next we have to calculate the FL or formation level for all the other RDs. Now as you can see, if we need to calculate the cut and fill quantities, we of course need the area, and for area we need the depth, okay, at each RD. That's why we need FL of the each RD. So we're gonna calculate formation level of the remaining RDs. Okay, just like the only thing I'm gonna do over here is to calculate the fall in bed for each 30-meter interval, and this is going to be the interval, which is 30 meter, that's given, divided by the bed slope. Okay, the bed slope is also given over here in form of, you can say, gradient. Okay, this one gradient at bed level is 600, and it is ratio, okay, 1. So it is slope of the bed and it is given, so I'm gonna divide the interval by that guy, and we got the fall in bed in each 30-meter interval equals 0.05 meters. So now we can calculate FL or formation level of the each RD, and we can do it of course if we subtract this fall from the first FL, you can say, like 233 minus 0.05, we get of course 232.95. That's so simple. And again we'll subtract this fall from the new formation level. So we got all the formation levels for the remaining RDs, like that. It's so simple. Now the next thing we're gonna calculate is the depth per each RD, and this is so simple. Okay, we're gonna just subtract the FL from the NSL. Okay, like for example, if we need to calculate depth at RD 800, that is going to be the NSL, which is 235.5, minus the FL, which is 233, and that is going to be the depth at interval or at RD 800. Okay, and that is just 2.5. So simple. And again, if we need to calculate the depth at RD 830, we can just subtract the FL, which is this guy 232.95, from this NSL, which is 235.8. So to get the depth at RD 830, we just subtract this guy, okay, the FL, and that is going to be 2.85, and so on, the same thing. Okay, just do it. Okay, so once we got the depths at each RD, then of course we can calculate the mean depth at each RD by adding two depths and divide it by 2, okay, by the number of depths. Okay, like as you can see, I'm just gonna add these both guys, like 2.5 plus 2.85 divided by 2, so we get the mean depth at RD 830. And the same thing, okay, like 2.85 plus 2.35 divided by 2, we get of course the mean depth at RD 860. Do the same thing for the remaining. Okay, so next thing we got over here is areas. For areas we have two portions. One is the central one, like this one, which is BD, and another one is SD square, and this is for the sides. Okay, so BD means the breadth which is given, that is 5 meters, and the depth, this can be the mean depth. Okay, so for the RD 830 we got BD is 5 times 2.67. 5 over here represents the, you can say, the breadth, okay, at the bed you can say, and 2.67, this is of course the mean depth at RD 830. Okay, so this is of course 13.35, and do the same thing for the remaining RDs. Now SD square, this can be SD square divided by 2 if we got side slopes for both sides not the same. Okay, here we got the same thing, I mean the side slope for both sides are the same, that's why I'm going to use SD square over here. And now as you can see, which one side slope should be used over here, this one 1:1 or 2:1, that's so interesting over here. As you can see over here we got only cutting. Okay, how? Because NSL is a high value than FL, or you can say the formation level is lower than the NSL. And as you can see in this section, the section of cutting, NSL is just above the formation level. So over here we gonna just calculate and we'll just get the cutting quantities, not the filling. Alright, so SD square, S means the side slope, this time we got only 1 over here. Okay, and D is the mean depth. So for the RD 830, this can be 1 times 2.67 square, which is of course 7.13. Okay, and do the same thing for the remaining RDs. Just plug the side slope as 1 and the mean depth just at the front of that RD, you can say these things. Okay, alright, now the summation of areas, just add these both areas, the same thing in the same rows. Okay, like 13.35 plus 7.13, this is 20.48, and the same thing just like that. Now the distance, that means the interval, which is 30 meters, it's given. Okay, so now the quantities are the estimation of cut and fill. It is so simple. Now we have area and distance, so area times distance, that is volume or cut and fill. Like 30 times 20.48, that is of course the cut, which is 614.4. alright, and 19.76 times 30, that is the cut again, and 20.59 times 30, that is cut again, cut. Okay, that's so simple. Why cut always? Because the NSL is above the formation level, or NSL is high value than the formation level, you can say like that. If you got the formation level just above the NSL, then there can be filling. Okay, here we do not have filling over here in this example. Alright, so simple. Now just add all these above, so we can get the total cut for this irrigation channel, which is 3259.5 cubic meter. So here is the final result. Hey, if you like these types videos, please hit that subscribe button, press the bell icon, and never miss an update from an engineer boy.
Thank you dears for watching. See you next time and wassalam.